Alright guys, welcome to today's class. Today we're gonna continue the lesson off, and then we're gonna start a new lesson afterwards. Alright? Let's start with problem 27. How many different ways can Marco travel from Annandale to Boston? He may not visit any city more than once, and he must stay on the roads. Well, how many ways? So you notice that these things are symmetric. This entire thing is symmetric over this line. So we can find the amount of ways. So we basically can find the amount of ways to go from one side and then convert that to the other. All right. But in this case, since we have this part, this is not gonna work. Most of the questions that we're going to do this, we can if we have the symmetry, we can do it. But in this question we can't. Well, we still have the symmetry, but be careful about over counting. That's the only problem. All right. So let's just count. So from Annandale to Boston, how many ways? We have one, two, three, four, and then we can keep on counting. I'm just gonna skip the counting because it's just a bunch of casework where it just lists out all the possible values. But you'll eventually end up with the answer of A or 15 if you were to count it every single time. Why how does it make sense? Remember that we have a symmetry going on around here. Or symmetry. This line is not part of the symmetry because there's only one, there's no two. But each of these have a pair that can reflect over, right? So that just gives you it has to be odd. So E's not right. And then we just use casework to find out the answer is 15. Now let's move on to problem 28. How many four-digit odd integers greater than 6,000 can be formed from digits 1, 0, 1, 3, 5, 6, 8 if no digit can be used more than once? Alright, let's have a try this question and tell me what to chat. All right, let's get started. So basically, how do we approach this? No digit can be used more than once, and the first digit cannot be uh 0, and the last digit has to be odd. How do we approach this? We notice that since the integers have to be greater than 6,000, the only possible first digits are 6 or 8. Since the integers can be odd, the unit digits must be 3, 1, 3, or 5. Two choices for this one, and three choices for this one. We got 4. Now, after we choose 2, we got 1, 2, 3, 4, 5, 6, and the 6 minus 2 is 4 choose choices. So that's 4. And then we have 3 choices. Or 2 times 4 times 3, or 72, or B. Alright, now let's move on to problem 29. How many 3-digit numbers can be formed using the digits 0, 1, 2, 3, and 4? No digit can be used twice in any 3-digit number. Let's get a go at this question and 10 minutes to do chat. Yes.
I couldn't see.
Can you see now?
Yeah.
All right, guys, let's get started with this question. So basically, how do we approach this? Now, notice that we have three-digit numbers that can be formed with 0, 1, 2, 3, and 4. We got 5 digits. And no digit can be used twice in any such three-digit number. There's no restriction on the last digit. There's a restriction on the first digit, meaning that we can't use 0 as the first digit. Because all three-digit numbers do not use 0 as the first digit. So from there, we can get there's four choices for the first digit, four choices for the second, and three choices for the third, which gives you a total of 16 times 3 or 48, or D. Alright, now let's move on to problem 30. Five students are sitting in a row. Axe and Bob are not sitting next to each other. How many arrangements are there? We're going to use complementary counting on this one. We're going to count the opposite method. We're going to say how many ways are there that Alex and Bob are sitting together, subtract that from the total to get how many ways are Alex and Bob are not sitting together. Total is 5 factorial, or 120. Now, how many ways if Alex and Bob are sitting together? Well, let's think about Alex and Bob as a new person. As, let's say, Charles. And so we have, after that, we're gonna have three people and Charles. Because Alex and Bob is part of Charles. And then there's three students minus Alex and Bob. This is just four factorial ways, since Charles is another person. So there's a total ways to arrange four people is just 4 factorial times, oops, times 2, because there's two ways to arrange Alex and Bob in order, or 48. Subtracting gives 72 as our answer, or B. Alright, now let's move on to problem 31. Using four different colors to color the rectangles A, B, C, D as shown in the figure, no two rectangles are sharing the same edge can be the same color. How many ways are there to color the rectangles? Let's get that try this question and tell me answers to chat. Alright, guys, let's get started with this question. So we have four different colors to color these rectangles. And no two rectangles can share the same color. How many ways can there to color the rectangles? Now let's start with the A. A has four choices. Okay? Now B and C cannot be the same color. I mean, B cannot be the same color as A, and so can C. Cannot be the same color as A. What can I do from there? Since they're not the same color, this guy has three choices. This person also has three choices. Why? B and C do not share an edge. So that means that they, since they do not have an edge in common, they can be the same. Now, since C and B share an edge with D, that leaves us with two choices because A does not share an edge with D. Alright? That gives you a total of 4 times 3 times 3 times 2 choices, or 7. 4 times 2 is 8 times 9 is 72. Right? Seems like, but are we undercounting? Let's try a different way because I might be undercounting over here. Let's see. Case one, A, D are different colors. Let's say if A and D are different colors. So A has four choices. D has three choices. Since they cannot be the same as A and D, this guy has two choices, and so does this one. So that's 2 times 2 times 4 times 3, 48. And case two is A and D are the same color. That means that it has four choices for this one, or this becomes one. So it becomes 4 times 1 times 3 times 3 because they're the same and their only difference is that they're the same color, so we have to subtract 1 to get 3 and 3. Plus 4 times 1 times 3 times 3, or 36. Adding this up gives you 84. So I was overcounting. I meant undercounting. This is why we make sure we gotta check the answers to make sure they're the same, because if you don't, then we might be undercounting or overcounting. Like in this method, we were undercounting. Alright, so the answer to this question is just C. Now let's do example 30. How many three-digit palindromes are there? This is divisibility now. How many? Well, what is a palindrome? The definition of a palindrome is a number that, when reflected, say the number is ABA. If we reflect it over the middle, we switch it up, we should get the same thing, or ABA. Or in this case, 1 to 1 can reflect to 1 to 1. 1 to 3 reflected, 1 to 23 reflects to 321, which is not a palindrome. This case, how do we approach this? Notice that the first digit has only 9 choices, so the third digit has only one choice because they're the same thing. The middle can be any of the 10 digits, or 9 times 10. And we multiply by the 1 to get 90, or C. Right? Now let's move on to divisibility. Divisible by means when you divide a number by another number, the result is a whole number. Alright, I think you guys understand it. The expressions ABC, ABC, and ABC, one with a overline, one is the underline, and one is ABC, are basically 100A plus 10B plus C, or the base 10 notation. They are represent the three-digit numbers such as 234, 234 equals 234. A number is divisible by 2 if the last digit of the number 2 is divisible by 2. Number is divisible by 4 if the last two digits of the number is divisible by 4. In general, a number is divisible by 2 to the n if last n is equal to is divisible I should say last n digit by 2 to the n. That's the basic answer. Now, why is that? How do we prove this? Well, notice that the last n digits. Think about this. The first n digits. Let's write basically, let's say in this case, we have 10 digits. And we want to see if it's divisible by 2 to the 4. Right? For example, let's say a 4 digit. C divisible by 4. Let's say it was 1032. Well, let's look at this part. Okay? This part over here. This can be written as 10,000. 1,000, I mean. Now, notice that 4 divides into 100, or 100 is divisible by 4. This is this part. Now we got a 10 extra. This just tells you that this expression right here is divisible by 4. 1,000 is divisible by 4. So now all we have to do is ignore this part because we know it's divisible by 4 and look at the last two, in this case, 2 digits. Why is that? Since any power of 10, say 10 to the n, can be written as 2 to the n times 5 to the n. And that's where the 2 to the, that's where this 2 to the, that's where the last n digit come from. Right? 5, it's the exact same thing. 5 is, if the number is divisible by 5, then the last digit is 5, 25, 125, and 625. A number is divisible by 3 if the last sum of the digits is 3, divisible by 3, and a number is divisible by 9 if the sum of the digits of the numbers is divisible by 9. Alright, let's do, and then we are going to add into this one. The divisibility rule for 7, 11, 13. To find if the number is divisible by 11, add every other digit and call that sum x. Add together the remaining digits, call the sum y. Take the positive difference of x and y, or the absolute value of the difference between x and y. If the difference is 0 or a multiple of 11, then the original number is a multiple of 11. Alright, an example is, say we have 1, 1, 1, 1. We add these two together. We add every other digit, or we try every other, which is just, say we get the first digit, we skip the second, we add it the third digit, and then we skip the fourth and we add the fifth digit. Do the same thing for the second digit, we skip the third and we add fourth, and so on. That's basically what it means by every other. So basically, after adding these up, we get each of the sums is 2, subtract, and you get 0. If the difference is 0 or multiple of 11, then the original number is a multiple of 11. And that's where we get it from the works. If the positive difference of the last 3 digits and the rest of the digit is divided by 7, 11, or 13, then the number is divisible by 7, 11, or 13, respectively. And then another divisibility rule for 7. If you double the last digit and subtract it from the rest of the number, and the answer is divisible by 7, then the number is divisible by 7. You can apply this rule to that answer again if necessary. Well, you can actually make more divisibility rules. For example, if you do triple, I think it was 31. Correct me if I'm wrong. And then this is basically factoring. I use factoring to get divisibility rules. Let's start. Example 1. If the 3-digit number 78n is divisible by 4, how many possible values of n are there? Let's see if I have a try on this question and tell me this to chat. All right, guys, let's start with this question. So, how many ways? We want to find all n such that 8n is divisible by 4. All right? How many ways? Well, it's funny. If n is 0, we get 780, which is divisible by 4, because 80 is divisible by 4. If we add 4, we get 84, which is also divisible by 4. Add another 4, we get 8. 88 is divisible by 4. So the answer is 3 or A. Alright, now let's move on to example 2. A three-digit number contains, three-digit integer contains one of each of the three digits 3, 4, 5. What is the probability that the integer is divisible by 5? I'll let you guys have a go with this question and tell me the answer to chat. Alright, guys, let's get started with this question. How do you post this? Notice that 5 has to be the last digit. Alright? 5 has to be the last digit. Now, what's next? 3 and 4, they can be interchanged, meaning that they can be in the first or second. They have two ways. So the way number of ways is just 2, and total number of ways is 6, is 2 divided by 6, or 1/3. Right? Now we're doing example 3. The 6-digit number 713EF5 is divisible by 125. How many 6-digit numbers are there? Alright, how do we do this? Notice that it can be either 125 or 625, the last two digits. So that's a total of 2 possible ways. Or EF is 1, 2, or 6, 2, or 2. Alright? So that's it for today's lesson. I hope you guys have a wonderful weekend, and I'll see you next week. Bye.